In this video, I'm going to be introducing you to the first derivatives. This is when we need to find the first derivatives of functions. Okay, so here I want you to see, can you spot the pattern? So you can see in the first row here, we have all these x's to different powers. And then on the next row here, I'm going to be finding the first derivative. Okay, let's see, did any of you spot that? So what I was doing, I was multiplying by the power, then reducing the power by 1. And that is the method. You can see here in the orange box as well, more technical, you can see if you have y equals a x to the power of n, then dy dx, you can see it's a then times n, and then you reduce the power by 1. So that is how we do it. So the first one there, you can see y equals x to the power of 8. So then on the next row now, I'm not writing y, I'm differentiating. So then I write it as dy dx equals now, so multiply by the power, so it becomes 8x, then reduce the power by 1, so it becomes 7. You can see up here as well, I have a y equals f of x. So you should know that already from functions, that your y is the same as f of x. But then when you differentiate it, y goes to dy dx, and f of x goes to f dashed of x. So again, these represent the exact same thing. Okay, if you look at the next example here, so I'm differentiating, so it's going to become f dashed of x. So now, multiply by the power, so 2 times 4 is going to be 8. X then reduce the power by 1, so it becomes the power of 3. The next one then is s equals, so it's not y equals, so in this one it's actually going to be ds over dx. Okay, no, because there's no y, it's an s, so it's going to be ds over dx. So multiply by the power, so it becomes a quarter. And then a quarter minus 1 will be minus 3 over 4. And that's it. Okay, let's have a look at the bottom one here. So we have y equals x to the power of 4 plus 3x squared minus 5x plus 2. So finding dy dx. So x to the power of 4 will be 4x power 3. Next one, multiply by the power, so 2 times 3 is going to be 6. Reduce the power by 1. So that would be 6x to the power of 1. But we never actually write x to the power of 1. So I'm just going to leave that as 6x. Now, minus 5x. So when you just have a number with an x, you're just left with the number then. So that'll just become minus 5. And then the 2, that just disappears. So that's gone. So your answer is 4x to the power of 3 plus 6x minus 5. Okay, let's have a look at this one here. So we have a big, long expression here. So let's do dy dx. Now, multiplying by the power, so 4 times 4 is 16. Then it's reduced the power by 1, so it becomes the power of 3. Again now, 10 times 3 is going to be 30. X now squared. 2 times minus 2 would be minus 4. And then remember, x squared just becomes x. Now the minus x, that will become minus 1. And then the 10 just is gone. So that's my answer then. Okay, so these 3 questions have come up in the Leaving Cert Ordinary paper before. So if you want to pause the video and give these a go, and then when you want to see the solutions, press play. Okay, let's see how you did. So, first one here, we have the function f of x equals x cubed plus x squared minus 2x plus 7 is defined for x is an element of real, and then we need to find the first derivative. So f dashed of x. So f dashed of x. So x cubed will become 3x squared. X squared then, so will become 2x. And then minus 2x will become minus 2. 7 is gone, so that's our answer. The next one then, notice it's not y equals or f of x equals, it's a equal to. So then it's dA dx is what we need to find. Now, 10.5x, like in the previous one when we had minus 2x became just minus 2. 10.5x, that'll just become 10.5. Then minus x squared will become minus 2x. And that's it. Okay, last one then. So we have dy dx equals 3 times 2 now, so you're going to have 6x squared minus now 2 times minus 3 would be minus 6. Reduce the power by 1, so we have 6x. Then the minus 1 just disappears. So we're left down with 6x squared minus 6x. And that's our answer. Okay, any questions, please leave in the comments. Thank you.